Now, in the traditional geometry, we have the point, and we also have a straight line, and then we can use the straight lines to form some figures, okay, or this kind of figures. And we can put all these geometrical features onto the XY plane, and we can study it again. So we put all the things onto the XY plane. Now, here's a point P. For example, here, from the origin to here, it is 4. And from the origin up to here is 3. And we can say that the position of the point P is 4, 3. We say this is the ordered pair. Ordered, that means 4, 3 is not equal to 3, 4. And where is 3, 4? 3, 4 is here. This point is 3, 4. So 4, 3 and 3, 4 are two different points. You can also put the straight line onto the XY plane. For example, here. And we can also have the figures like this, or triangle like this. Do you know what is the advantage when we put all the geometric figures onto the XY plane? One of the advantages is we can locate a point accurately, and also we can find the distance between 2 points. So we now go to see how to find the distance between 2 points. Now we have the XY plane again. Suppose that the point A, the position is 4, 1. And another point B, the position is 7, 5. And we know that what's the meaning of 7? 7 means from the origin up to here, 7. 1 here, and from here to there is 5. So we know that we can draw a triangle like this, and we want to find the distance between A and B. Now, because it is a rectangular plane, that means the x-axis and y-axis intersect at a right angle. So here's also a right angle. Now, the vertical distance is 5 minus 1. Here is 1. 5 minus 1. And 7 minus 4. The distance between A and B is by Pythagoras theorem equal to this side 7 minus 4 square plus 5 minus 1 square. We take square root on both sides, and then we have AB equal to square root 7 minus 4 square plus 5 minus 1 square. Can we go to the general case? Say the position of point A is x1, y1, and the position of B, that means the coordinates are x2, y2. x2 minus x1 becomes the distance between this point and this point, x2 minus x1. How about this vertical distance here? It is y2 minus y1. So instead of this expression, we have y2 minus y1 square plus x2 minus x1 square. And then we take the square root like this. It becomes the length of AB, the distance between A and B. And sometimes we write the symbol like this. Sometimes we drop it out, just AB. So this is the distance formula. Distance formula. We can go to the slope formula. We have
3 hills here. The first hill like this.
And the second hill like this. And the third hill like this. There's a boy. He wants to walk along the hillside and to the top of the hill. Can you say that which slope of the 3 hills are steepest? Steep. The hill A, hill B, or hill C? In our living experience, we know what's the meaning of steepness. But in mathematics, we have to find a tool to express the concept of steepness. Well, there's a way. The boy, when he wants to walk from this point to that point, that means he has to move by a horizontal distance, and then there's a vertical distance here. For this case, the horizontal distance and the vertical distance. How about this one? The horizontal distance and then the vertical distance. You can see that the horizontal distance are the same, but the vertical distance are not the same. The bigger the vertical distance, that means the hill is more steep. Now, the horizontal distance are the same, but the vertical distances are not the same. The higher, the bigger the vertical distance, that means the slope is more steep. Okay? And then we have a measure. The measure is draw a triangle. We have the vertical distance over horizontal distance. We have a slope expressed as a fraction, vertical distance over horizontal distance. Now, say, again we have the xy plane here. There's a point, for example P, the position is 2, 3, another point Q, 10, 7, and there's a straight line joining P and Q. And what is the slope here? The slope is equal to, first, draw the right angle triangle like this. And here, the vertical distance is 7 minus 4, y2 minus y1. And the horizontal distance is 10 minus 2, x2 minus x1. So we can get it. Slope equal to 7 minus 3 over 10 minus 2. In general, if Q is x2, y2, and the P is x1, y1, then slope equal to y2 minus y1 over x2 minus x1. In this case, it is 7 minus 3 over 10 minus 2. Of course, you can compute, you can find out the figure for this. It is 4 over 8, that is 1 over 2.